Hello everyone, welcome to Physics NP. Today we are going to discuss numerical questions on surface tension. We have three types of questions in this chapter. The first one is on your screen. A rectangular plate of dimensions 6 cm by 4 cm and thickness 2 mm is placed with its largest face flat on the surface of water. Calculate the downward force on the plate due to surface tension assuming zero angle of contact. What is the downward force if the plate is placed vertical so that its longest side just touches the water? So here we have a rectangular plate having length 6 cm, breadth 4 cm and thickness 2 mm. 6 cm is 0.06 meter, 4 cm is 0.04 meter, and thickness is 2 into 10 power minus 3 meter. Now we have two cases. In the first case, the plate is placed with its largest face flat on the surface of water. So just like this. The rectangular plate is placed like this, and here is the water. So when the plate is kept flat on the surface of water, the lower surface is in contact with the water surface. So in this case, length length of contact with water is equal to L is equal to perimeter of the base, that is 2 0.06 plus 0.04, this is equal to 0.2 meter, and hence uh, downward force will be equal to surface tension into length of contact. By definition, write it different. L, length of contact capital L, and surface tension of water is 7 into 10 power minus 2 into length 0.2, which gives 1.4 into 10 power minus 2 Newton. Similarly, one thing given over here is surface tension of water is 7.0 into 10 power minus 2 Newton per meter. Now second case. In second case, plate is placed vertical so that its longest side just touches the water. So in this case, the plate is placed like this, and this surface is in contact with water. This surface is in contact with water. So here, length of contact length of contact will consist of this length, which is thickness, and this length, which is length, two times. That means length of contact is 2 times length plus thickness. That is 2 times 0.06 plus 2 into 10 power minus 3. This will be equal to 0.124 meter on calculation, and hence force, downward force, is equal to surface tension into length of contact, and this comes to be 7 into 10 power minus 2 surface tension, length of contact 0.124. This gives 8.68 into 10 power minus 3 Newton. Okay, these are the solutions of the first question in both the two cases. Now here is the second question. Find the work done required to break up a water of radius 5 into 10 power minus 3 meter into 8 drops of water. Assuming isothermal conditions, given surface tension of water 7.2 into 10 power minus 3 Newton per meter. So the first thing we need to understand that one drop of water, a bigger drop, of water, is break to 8 small drops. According to the question. First, what we consider, let R be radius of big drop, this one, and small r be radius of small drop, this one. Now since one big drop is split into 8 small drops, here the volume of big drop must be equal to 8 times volume of small drops, since the bigger drop is baked to the 8 drops. Now in such case we will apply the formula of volume. Sphere drop is a spherical shape, so volume is 4 by 3 pi r cube is equal to 8 into, and volume of a small drop 4 by 3 pi small r cube. 4 by 3 cancel, r cube is equal to 8 times small r cube, and r cube is equal to 2 power 3 r power 3, so finally r is equal to 2r, and the radius of big drop is given 5 into 10 power minus 3 meter. So small r will be equal to capital R by 2 is equal to 5 into 10 power minus 3 by 2. This is equal to 2.5 into 10 power minus 3 meter. So first we have calculated the radius of the small drop, and now since one drop is break to 8 drops, there will be obviously change in area, surface area. So first we will calculate the area of bigger drop and then smaller drop. Again, area of big drop, surface area. So drop is spherical, area is 4 pi r square is equal to 4 pi into 5 into 10 power minus 3 square. Similarly, area of 8 small drop is equal to 8 into 4 pi r square, that is 8 into 4 pi into 2.5 into 10 power minus 3 square. Now we will subtract them. Obviously this is the bigger area, this is a smaller area. We will subtract them to calculate change in area, that is del A is equal to 8 into 4 pi r square minus 4 pi bigger r square. Putting the values, 8 into 4 pi into 2.5 into 10 power minus 3 square minus 4 pi into 5 into 10 power minus 3 square, and subtracting, how much we get is 3.1416 into 10 power minus 4 meter square. So this gives the how much area is increased when we break one drop to 8 drops. And now finally we need to calculate work done. Work done to break this. So in case here work done is defined as surface tension into increase in area. So as given in question, surface tension is 7.2 into 10 power minus 3, 7.2 into 10 power minus 3, and increase in area is 3.1416 into 10 power minus 4. This is calculated as about 2.26 into 10 power minus 5 joule. So this is the solution of the second question. The third question on surface tension is on your screen. Mostly we get these types of questions during in examination. A capillary tube of 0.3 meter diameter is placed vertically inside a liquid of density 800 kg per meter cube. Surface tension 5 into 10 power minus 4 Newton per meter and angle of contact 30. Calculate the height to which the liquid rises in the capillary tube. So what we must know, that here a capillary tube is kept in a liquid. This is the capillary tube, and when we keep the capillary tube inside the liquid, the level of liquid rises inside the capillary tube to certain height. We need to calculate the height, how much liquid rises in the inside the capillary tube. So here the given quantities are diameter of the tube is 0.3 meter, so radius is half of the diameter, that is 0.15 meter. Similarly, density of the liquid is 800 kg per meter cube. The surface tension of the liquid is 5 into 10 power minus 4 Newton per meter, and angle of contact is 30 degree. Now we have a direct formula to calculate the rise of liquid. Height of rise of liquid is 2t cos theta by r rho g. Putting these values, 2 into surface tension 5 into 10 power minus 4 into cos 30 degree angle of contact by radius 0.15 into density 800 into g, value of g 10, and on substituting these values and solving, we get the value as 7.216 into 10 power minus 7 meter. This is the value how much liquid will rise inside the capillary tube. So these were the major three questions generally asked uh, in the topic of surface tension. Thank you. Thank you for watching.